He's a professor at the University of Chicago.
No.
Or University of Chicago, sorry. He's also co-director of the Energy Policy Institute at Chicago. He's a former chief scientist at Argonne National Lab and associate lab director. He's also from 2002 to 2005, and Argonne's laboratory director from 2005 to 2009.
Okay, that's it. So what I'm going to do is give you kind of an overview of what we're about in the Energy Policy Institute at Chicago. And the starting point is really this slide, which is that is a claim that I would like to make, which is that wealth creation is tied to the use of energy, and historically it's also been tied to environmental degradation. So the history of what we've done over the past 100 years is, certainly in the Western world, what we sometimes call the developed world, is to make a lot of money, to become wealthy, and you can see that graph on the left shows that, and while we've been doing that, we've been consuming mostly fossil fuels, and we've been putting CO2 in the atmosphere, other things in the atmosphere besides CO2. But while we've been controlling the emissions from the point of view of NOx and particulates, we have not been controlling the emissions related to carbon dioxide. You can see the inexorable rise in CO2 abundance in the atmosphere, and of course, I could show you the same kind of plot, for example, for acidification of the oceans. Now, the interesting question is, what do we do given the fact that this is a worldwide problem? This is not a problem just in the United States. This is a problem that all of us who live on Earth have. And the question is, what is our role? And by our, I mean here in the United States. What do we do? So the first point is that when we look at CO2 emissions per capita, the interesting thing is that the developed world has since the 70s actually been decreasing the CO2 emissions per capita. And there are many reasons for it. The reasons, interestingly enough, differ country by country. They're not all the same reasons, but there's no question that they've been decreasing. And the starting points, of course, are very different. If you compare, for example, the United States with this pair of Germany and the United Kingdom, or the other pair that's interesting here, which is France and Sweden, we are way, way, way above everybody else, and I think we all know why that is. It has to do with two factors. One is the way we live. Dispersed, we love suburbs, we love to be dispersed, we love to travel, and the amazingly cheap energy that we have. Unbelievably, we basically don't tax energy consumption in the United States, whereas in other countries, we do. If you look at the difference between the pair of Germany, United Kingdom, France, and Sweden, there's another effect there, which is that in the case of France and Sweden, they've decided to basically focus on either renewables or nuclear as their primary way of generating base power. So, for example, in the case of Sweden, roughly speaking, half of their power, electricity is produced by hydro, half by nuclear. In the case of France, almost 80% is produced by nuclear. And that's the difference between those two countries and Germany and the United Kingdom, where much of the base power is still produced by fossil fuels. So this is a picture of for much of the developed world. If I had put on here, Japan would have actually been very similar. But here's the rest of the world. So in developed countries, you can see the darker blue. In sort of greenish color, you see what's happening in the developing world. And it's pretty clear that by now, we're no longer the chief contributor of CO2 to the atmosphere. It's folks in the developing world. They are now dominating the impact of climate. And the obvious question is, now what do we do? So this is where we are today. We have China, India, Brazil, not only on track to dominate CO2 into the atmosphere now, but also for the rest of the century. And the evidence, for example, in the case of China, based on the number of coal plants that they're building, one, roughly speaking, one every week, is that their energy sectors are going to be based largely on fossil fuels, not for the next 10, 20 years, but probably the order of 40 to 60 years at least, because that's the typical lifetime of the industrial infrastructure that we're building today. So this is not, so the key thing to remember with energy technologies is, in a sense, they're for keeps. They last many, many decades. And their driver, as I've been given very clearly to understand by some of the folks that I've interacted with, both in China, India, and Brazil, is that the principal concern is economic and social, not environmental. They do focus on environmental remediation. So, for example, in China, there's a big push to get rid of the dirty coal plants. And what they mean by that is coal plants that emit particulates, that emit NOx. So the things that directly affect human health in the environment, but not CO2. And so for them, wealth creation is part and parcel of especially in the case of China, of maintaining social cohesion, making sure that they know sort of social habits. Now I mean broadly, we will have the chance to actually do something about CO2 over the past 100 years, quite frankly, and we we did nothing. And I would say after 2010, even the possibility that even if we did something wouldn't matter. That seems to have most I would say. The fact that we're going to continue decreasing our CO2 that we put in the atmosphere is nice. We will feel good about ourselves, but in terms of the overall effect on the Earth's atmosphere, will not have a major effect, unfortunately. And more than that, if you actually look at the various conferences that have occurred, international conferences, there have been lots of agreements, but actually no implementation. People are not following what they said they agreed to. So there's some obvious questions. One of them is has to do with are we stuck with inexorable rise in CO2? And the evidence right now is so are we going to really have restrictions on CO2 emissions in the developed world that make a difference? I think the answer is no. Is there a consensus on whether or not you can both capture and sequester carbon in a way that makes economic sense? And the answer is not so much. There's no consensus that people can say you can. The evidence is that the only people that can do it and make money are the people that are involved with tertiary recovery of oil, where the CO2 is used as a pusher gas. What's our ability to tell the rest of the world what to do? So I've been at international meetings where I've been told very directly, we don't want to hear from you anymore. Me as a American. So we love to lecture, but it's not effective. And so the obvious question is, can we do something? So what do we do? We just throw up our hands and say, well, that's it, or do something. So I think the answer is yes, we can. So the point is that we are facing what's often called the tragedy of the commons, in which no one has an incentive to behave well when it comes to the welfare of everyone else. And the reason is that there are no financial incentives to do that. So the fact of the matter is, just on the basis of financials, the push is always going to be to use the cheapest source of energy, and for the foreseeable future, that is going to be fossil fuels. Furthermore, the biggest impacts are going to be in places that A, can't defend themselves very well, and two, don't have very much money. Poor regions. Think of Bangladesh. Think of the Nile Delta. Think of all those places where for example, sea level rise will basically do them in, and they have nothing that they can do. And by the way, they weren't responsible for the same. So the question is, what could we do? And so what we've been focusing on at EPIC is to think about R&D developments that matter to the rest of the world. Most of what we do today, including, by the way, things here at Oregon, are focused on technologies that matter to us, not necessarily to folks in the developing world. So we will decrease our energy intensity. We will decrease our per capita carbon footprint. But on the developing world, we're not going to have much of that. So what should we invest in to make a difference? So the obvious question is, are there technologies that could make a difference elsewhere? And what are the barriers? And so I wanted to spend just a few moments talking about, I have one more slide, talk about one example. And the key thing to remember here is that typically the obstacles that developing world have is inappropriate or inadequate infrastructure, both on the technology side and on the infrastructure side. In China, a good example is the fact that the national grid is underdeveloped, especially when you get away from the coast. The scarcity of water inland as you go away from the coast. There isn't enough water really, and power, unfortunately, if you have thermal plants, you need water. And if you look at nuclear in particular, many of the countries that are wannabes want to have nuclear power really don't have the human resources, the appropriate resources to actually deal with it. Some countries will simply buy it. A good example is Abu Dhabi. They're wealthy, and they simply buy the infrastructure. That's what they've done. And of course, for some of us, it matters how you deal with the waste products, especially since the waste products contain plutonium, it's using the bombs on. So here's the kind of stuff that we've been working on. One is to ask, can you make a case, an economic case for nuclear power if you change the way nuclear plants are built? Nuclear plants today are built the way that we build houses in the suburbs. Some people call it stick building. With everything on site, with everything per location, the build rate is very, very low. So typically, the people that show up and build these nuclear plants have inexperienced. In the United States, we haven't built a nuclear plant in 30 years. We're not building two in the South. And you know that building those plants are basically that have never done this before. So basically, these plants are going through a period where they're basically learning how to build something. And you can bet that that's going to be expensive. So the question is, what can you do about that? And so we've been looking at small modular reactors. We've done some studies with industrial engineers to look at the learning curve of how good can you get when you focus on building reactors, small reactors, in a factory and then deliver it on site. What is the difference between when you do it for the first time and when you do it for the nth time, where n is something like 10. The other issue has to do, what do you do with nuclear waste? In a country like, for example, Vietnam. Vietnam has just signed agreements to buy 2 nuclear plants from the Russians. When you have a small number of nuclear plants, a repository is relatively expensive. And so the question is, because in these matters, scale is bigger, the repository, the cheaper it is, and Vietnam will never have a large repository. So the question is, what are the issues that a country like Vietnam faces in order to have a place where the stuff can be deposited? And we've been looking at multilateral waste repositories, actually in the first place, interim storage facilities. One of the debates is whether or not if you put something in the repository, it should be retrievable, not retrievable. What are the liability issues? The surety issue. The surety refers to being able to track the materials, where the plutonium is at all kinds of safety issues. And what's interesting here is that this is a technology where the United States can really contribute hugely, even though we ourselves may not want to. So this is something, it's a very good example where the United States, because of its technological capabilities, can actually help other countries without necessarily getting the stuff that they're actually needing the stuff that they're needing. So that's it.
Thanks. Any questions?
good thing to do.
I agree.
No, what will motivate that to actually happen?
To be crass about it, we, the Department of Energy actually has a program for small modular reactors. They've had two competitions. One happened last year for vendors to come together, to put together a proposal for the design and eventually building of a pilot small modular reactor. Last year, the competition was won by a consortium that involved Intel, BMW, and the TVA. And their reactor is a fairly small affair. It's around 50 megawatts a unit. It's quite small. The ongoing competition, I don't think, I don't know when they're going to announce the result, but there were at least 3 other consortia that are interested in it. So there will be, in the United States, there will be a few consortia that are going to design and build a project.
But many of the places that need them don't have the funds, so it's going to be the World Bank or the IMF.
How do you fund it?
Yeah.
Okay. Well, consider Vietnam. So Vietnam would be a case in point. Okay? So the way they're funding it is they're getting financial support actually through the Russians are extending credits. And I think that would be the case in all the examples. Abu Dhabi, they just had money. We spent quite a bit of time in Southeast Asia, and it's clear that maybe Thailand, all the other players are interested in it. They announced to the IAEA that they want to do this. There's a 19-step program that they can go through to prepare the country for nuclear power. And so Philippines, Indonesia, Singapore, Malaysia are all participating in it. Good.
Talk a lot about Southeast Asia, but you didn't say anything about Africa, and a lot of business analysts are talking about.
Yeah. So Africa is Africa is really 3 different places. Okay, so there's the north,
Right.
the Arab north, the middle, and South Africa. So South Africa has already the technological capability because they actually at one point were even in the business of building a bomb. Some people say that they actually did. And they retreated. So in fact, they have been in the lead to develop a new kind of nuclear reactor called Pivot. Whether or not they're going to go in this direction is something. If you look at the Arab North, there's certainly a bunch of articles. Egypt probably the lead. But I think the turnover is so great right now that I think there's a huge question whether or not anybody's going to actually do it. We actually have spent quite a bit of time when we talked to the Arab League, and there was a lot of enthusiasm if you go back 5 years. But with the interesting thing about the Arab Spring, it kind of put the kibosh on progress in this area. In the middle, there is a very different story. There, the social instability is just so huge that no one in their right mind would place a nuclear reactor. It's hard to find a country. I mean, the most developed, which the money, is Nigeria. And Nigeria is so incredibly unstable. I think you'd have to be crazy to think that you could put a plutonium-producing device in Nigeria.
As a follow-up, if I may, do you think the president's Power Africa initiative has any, or I guess first of all, is what the technology you're talking about, is that part of that
Yes.
strategy?
Yes.
And do you think, are you hopeful of something like that making headway, or is that just sort of a one-off project?
No. So actually, one of the studies, the second one, the SMR study, was done actually for the Department of Energy. So the administration was interested in the answer of how well can you do if you go to that production. The study on the back in the nuclear fuel cycle is being done through the American Academy of Arts and Sciences, and they have a start part of a program called Global in the Future, that focuses on this issue of how do we deal with the spread of nuclear power worldwide, given the fact that there are proliferation issues, safety issues. How do you do it in a way that Americans don't come across this country?
Questions? I think we'll move on to our next panelist, but thanks for the intro. I think it was a really good overview of some of the big picture issues around the world. So our next speaker is Leah Gazowski from Argonne National Lab. She's an energy policy scientist in the Decision and Information Science Division there. And she's also currently leading the lab towards multidisciplinary energy security team. And she'll talk more about that and some of the global initiatives that they're doing.
Thank you, Scott, and good morning. It's good to be here. I'm going to talk about two things today. I want to first just give a brief intro onto how we at Argonne are approaching energy security. And there are many aspects going on here, so I'll, for the sake of time, I'm going to keep it on a pretty high level this morning, but if there are specific follow-up questions, I certainly welcome those. And then I will give you an example project that we're working on right now, and I'll talk a little bit about how I think that applies to energy security and energy policy. So, leading the energy security work that we do here is a bit of an interesting question because I go to these talks and conferences and it's very easy to spend the entire time getting into a discussion about how one might define energy security. And certainly, there are many, many ways to do that, and I really don't think that's the point. And I think it's very important to start these conversations off with a mindset. And I'm looking for something better because this is an old concept and notion, but it's that of a wicked problem. And I think that this is helpful because it gets us to move on from kind of this nebulous concept of energy security and allows us to have a more meaningful discussion. So this concept of a wicked problem has 10 key points, and I won't go through all of them. You start to get the flavor of what these might be. We like to be comfortable in a policy environment where there really is no end game here. There's no stopping road. There's really no immediate or ultimate test of what a good solution will be. And there's really no opportunity for a trial and error approach because these are very critical issues. The other points that this describes talks a little bit about how every problem in energy security is somewhat unique, but they're also very interdependent. And so these are all things that, as working in policy, that we need to learn to be comfortable working in and kind of move beyond that kind of, how do we define this, how do we think narrowly, how do we think largely, we need to move beyond those kinds of questions. So that all said, it's still very important to think about how can we just define energy security for the point of discussion. And we really focus on 4 key aspects: affordability, reliability, sufficient, sustainable energy. So those are really the 4 different areas that we break our work into. So I think it's interesting when we talk about energy security, many times we want to just talk about source diversification, and that's very important. That's something that we do quite a bit of here at Argonne. We're working on developing technology and the tools to do that. But I look at it from the angle of we also need to think about different considerations, such as what are the geopolitical considerations. So for instance, right now we're working on a project where we're looking at the South China Sea lanes. How does that affect energy security, and how can we use our tools and analysis to inform policy for the U.S. with regard to that region? What are the economic and policy considerations? And I think we can break that into a number of different points. For instance, what are the global choke points that we might have with our supplies? And then the critical materials. How do we start thinking differently about, as new sources come online and we depend on different sources of energy, how does that change what our materials might look like, and how does that change what our supply chains and logistics look like? So I'll start to segue a little bit into a more specific project. And Bob started to touch on this a little bit this morning. But one of the main things that we really do spend a lot of time thinking about is we have a change going on right now in the world, and that is we are seeing the world move to environment, and it's very timely to see where this line intersects. It is really just about right now. Now, we in the Western world, in the U.S., we've been a largely urban population for quite some time, but this is a relatively new change in the rest of the world. This is something that we spend a lot of time thinking about. How will that change the energy security, not just for the U.S., but globally? So one of the things that we're thinking about is how do we make more intelligent cities, and how do we use things like sensory controls, how do we use predictive analytics, and how do we use computational models to better understand how we plan and build cities. So I think this is a fairly telling picture from NASA. We're looking at Beijing right now, and the blue areas right here are urban environments. And you can see the change from 1977 to 2011 is really significant. So in the grand scheme of things, this is a very short time period that we're seeing very significant change. And as this happens, of course, very naturally, people who are moving to urban environments are requiring and demanding more energy, more power, more transportation fuel, and alluding to Bob's point, how we do that is certainly a question. So that's a NASA image, but let me show you kind of a human image of what this also looks like. This was about 2 weeks ago in Harbin when the smog was so great that it essentially shut down the city. This is people walking. We got to the point where they came out as saying, we're not even going to cite people if you run a red light because maybe we can see the red light from where your car is. So I think there's a very human element here that we need to remember because it's very easy for us, I think, sitting here to kind of think, well, what's going on in the rest of the world? And I think that human element is certainly very important as we inform policy. So here is a picture of about a 600-acre site on the southeast side of Chicago. It's called the Lakeside Development Site. And we, with a number of partners, are working to actually figure out how do we build, plan, design cities in a more efficient way. And what we're really excited about is we actually have a test bed to do it, this site. Now, part of the research here is started off with my colleague, first my name Charlie Catlett, and I. We started thinking about how do urban planners really work right now. And we started talking to developers, we started talking to consultants, architects, engineers, and we thought it very interesting that the way it works right now is that typically a developer might have a site like this, and they're very comfortable working at a scale of about 30 to 50 acres. But when you start looking at scales of 600 acres, that's a whole unknown. And how do we plan to develop this in a way that meets those four criteria? The affordable, sustainable, reliable, and sufficient energy. So this is it's a different question. We don't really know how to do it. So what we're doing here is we're trying to come up with a new computational model that we can actually integrate different systems. So as I said before, they kind of do this on kind of a gut level basis right now. And what we're trying to move this to is a more informed, science-based decision-making process. So instead of just saying, I'm going to hire a consultant to go out and do the energy planning, they go out and do it, they come back to some report, and then you hire a water person and they do the water planning, and then you hire someone to do the air quality and they do the air quality. And you're making all these decisions separately. So what we think we need to do is have a way to actually do this in a more real-time mode and be able to understand the interdependencies between the different systems with a site like this. This is what we think the site might look like. This is an artist's rendition. Certainly who knows what it will look like. But we think what we do here in a site like this will have tremendous impact in cities that are growing up at much faster rates across the world that are facing these urban questions. So how does this really relate to policy? Well, let me share with you my thoughts on that. I think this relates to policy because typically when you're building and designing cities, one of the key questions comes up, I'm a developer and I need to take a question mark to the city or I need to inform policy. Well, right now we're really doing that largely just based, like I said, on, we think we need to do this because here's why. Well, what we want to do is inform policy